Okay, part of the test for 8th grade will be that they are working on their factor trees. So they'll have a question like, write the prime factorization of each number in exponential notation. So we're gonna go for number 21 to use as my example. What you're gonna do is you're gonna find two multiples of 60. So any numbers that go into 60. I'll go with 2 and 30. Once you get to a prime number, again, a prime number is something that cannot be divided by anything other than itself or 1. So for example, 2 is a prime number. We're going to go ahead and circle that because we can't go any further with 2. We can, however, find some different multiples of 30. We can do another 2 and 15. And we're going to circle the 2 again because, once again, it's a prime number. 15, I can do another 2 multiples of 15. I can do 3 and 5. And both of those are prime numbers. So I need to now write my answer in exponential notation by taking my prime numbers and laying them out. So I'm going to have 5 times 3 times 2 to the second power because I have two 2's. And that would be my answer. Another thing that's going to be on the test for 8th grade is the product and the quotient of powers, which is basically saying when you have like terms like this, you can simplify the problem by combining your like terms and taking your exponents and adding them. We add them because it's multiplication. That is the product rule. And we are adding just the exponents of the like terms. So now, add them up and our answer is 5 to the 10th power. Same thing here, even though it looks complicated, it's really not. We have like terms of 3.2. Now we're going to go ahead and add the exponents. 4 plus 5, so it would be 3.2 to the 9th power. Now for division, it's different. The quotient rule is different because once you have your like terms, for example on number 6 we have the like term of m, we're not going to add our exponents together, we're actually going to subtract them. 9 minus 5. So our answer is going to be m to the 4th power. When you get down here to the fractions, again, it looks complicated, but it really isn't. We take our like terms of 3 over 4, which we're going to keep in a parentheses, and we are going to have 8 minus 5. So our answer is going to be 3/4 to the 3rd power. Now the reason we have to keep this in a parentheses is this is not equal to 3 to the 3rd power over 4. That's different. So we do have to keep those fractions within a parentheses before we write our exponent. The more complicated problems are going to look a lot like this one, which we will have 1 or 2 of these on the test. The first thing you're going to have to do is you're going to have to separate and categorize each term you have. So for example, I have 5a to the 5th power times 7b to the 4th power times 2b to the 3rd power. So the first thing I'm going to do is I'm going to separate all the numbers. So for example, I'm going to 5, 7, and 2. 5 times 7 times 2. Now I'm going to use all my variables, and I'm going to go in alphabetical order to keep this really nice and neat. So I'm going to use my a's, and I actually only have one a, and it's to the 5th power. So I'm going to now multiply a to the 5th power. Now I'm going to use all my b's. I have two b's. B to the 4th power and b to the 3rd power. Now I can go ahead and simplify my numerator by multiplying these together. 5 times 7 is 35, times 2 is 70. A to the 5th remains the same because it's my only a I have to work with. It's my only like term. And then b to the 4th and b to the 3rd can be multiplied together by adding the exponents and keeping the like term of b. So that's going to be b to the 7th power. So now I have a simplified numerator. Now I have to do the same thing to my denominator. I have b to the 5th power times 5b to the 2nd power times 2a to the 4th power. So again, first thing I'm going to do is take all my numbers. I have 5 and I have 2. 5 times 2. Now I'm going to take my a's. I only have one a, so I have a to the 4th. And I'm going to take my b's. I have b to the 5th power times b to the 2nd power. Now I'm going to simplify these by multiplying 5 and 2 is 10. There's nothing I can do with the a because it's my only like term. and then I'm going to multiply these together by adding the exponents and using the like term of b to get b over 7, or excuse me, b to the 7th power. So now I'm going to rewrite this just to make sure I stay organized and neat. Over 10a 4 b to the 7th. Okay, so these numbers right here, I can actually divide 70 and 10. 10 goes into 70 7 times. So when I divide that, that's going to come out to 7. Now, I wouldn't divide these, even though it says to, but my quotient rule says that when I have like terms, I can subtract the exponents. If I subtract 4 from 5, I'm going to get 1. But we don't really have to write the 1 because a to the 1st power equals a. Then I'm going to go ahead and I'm going to subtract again my exponents, 7 minus 7, which equals 0, and that would be b to the 0 power, but we know anything to the 0 power equals 1. And 1 times 7 is 7, so I'm going to keep this as my answer. 7a is my answer.